All right, let's talk about metal 3D printing. It's one of the most exciting technologies out there, but here's the big question. When is it actually the right tool for the job? Because let's be real, it's not a magic bullet. Today, we're going to cut through the noise and give you a super practical guide to figure out if it's the right move for you.
So this is the question, right? You see all the incredible things being made with metal 3D printing, and you're probably wondering, should I be using this for my stuff? It's a tricky one. I mean, for some folks, it's a total game changer. But for others, well, it can be a costly mistake. So let's get to the bottom of it.
You know the feeling, don't you? You get a quote for a new mold and your jaw just hits the floor. Or you've designed this brilliant but super complex part and you have no idea how you're going to actually make it. Or maybe you just need like 10 of something and the machine shops just laugh you out of the room. Yeah, these are the exact headaches that make people start thinking, maybe there's a better way.
Okay, so we've talked about the problems. Now let's get to the good stuff, the promise of 3D printing. And look, it's not going to solve every problem under the sun, but when it's the right fit, it is absolutely incredible. Let's see exactly where it shines.
And oh boy, does it shine. I mean, just check this out. A UAV frame that's 40% lighter? That's not just a number. That's way more time in the air. Or injection molds that cool 50% more efficiently. That's a huge boost to your production line. But this last one, this is my favorite. Taking 27 different parts for a satellite bracket and turning them into one single piece. That's not just an improvement, that's a total transformation.
And that's the key thing to grasp here. This isn't just about making the same old things just a little bit better. No, this is about making things that you literally could not make before. We're talking about patient-specific medical implants that fit perfectly, or parts with internal channels so complex they look like they were grown, not built. It's a whole new playbook for designers and engineers. And if you look at all these real-world examples, you start to see a pattern emerge. It doesn't matter if it's aerospace, medical, or something else entirely. The best uses for metal 3D printing have something in common. You see words like internal channels, honeycomb lattice, complex inserts. The theme here is pretty clear. It's all about tackling tricky, complex shapes that solve a really important problem. It's complexity with a purpose.
Okay, that was the highlight reel, but now it's time for a little reality check. Because being smart about this means knowing when not to use it. And trust me, that's just as important.
So let's be super clear about this. If you need a whole bunch of simple parts, like thousands of them, don't 3D print them. Traditional manufacturing is going to win every time. Got a simple, flat piece of metal to make? CNC is your friend. It's way faster and cheaper. And printing a giant, solid chunk of metal? That's just a bad idea. It's slow, expensive, and wasteful. Think of 3D printing like a scalpel, not a sledgehammer. You use it for the detailed, intricate work.
And just to really drive that point home, let's talk about screws. Say you need 10,000 of them. Thinking about 3D printing them? Well, it's going to cost you about 23 times more. Yeah, 23. That's not a maybe, that's a no way. It's a perfect example of using the right tool for the right job.
So, with all that in mind, how do you actually make the call? How do you know for sure? Well, we've boiled it all down to a simple 3-part test. Think of this as your go-to framework.
And here it is. It's a simple litmus test with just 3 questions. You need to look at the part's structure, the production efficiency, and the final application performance. Let's dive into what each of those really means. First up, structure. And the question here is simple. Is the shape of your part just a nightmare to make any other way? Are you trying to build in crazy internal channels? Does it need to be a custom, organic shape that fits a human body? Or are you trying to combine a ton of little pieces into one sleek, integrated part? If you're nodding your head yes to any of these, then ding, 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 you've just passed test number 1.
This quote really just nails it. The magic of metal 3D printing is that it doesn't care how complex your part is. You aren't limited by what a drill bit can reach or what a mill can cut. If your imagination is bigger than your machine shop's capabilities, this is where 3D printing becomes your best friend.
Okay, test number 2 is all about efficiency. And this is where the business side of your brain kicks in. Are you going to save a ton of time, money, or risk? Think about it. Could you slash your prototyping time from a month and a half down to just 1 week? Could you make a small, custom run of parts without paying a fortune for a mold? If 3D printing solves a huge headache in your timeline or your budget, that's a massive green light.
And last but definitely not least, test number 3, performance. This is where the rubber meets the road. I mean, it doesn't matter how cool or how cheap a part is if it breaks, right? So you have to ask,
Will the finished part be strong enough? Will it be precise enough? If it's a medical implant, will it be safe and biocompatible? The part absolutely has to perform in the real world. No excuses.
All right, we've gone through the good, the bad, and the how-to. Let's wrap this all up with the one key idea I want you to walk away with.
So here's the bottom line. Deciding on metal 3D printing isn't just a simple yes or no. The real question you should be asking is this a smart, strategic move for this specific part? And the way you answer that is with our three-part test: structure, efficiency, and performance. If your part aces that test, you've probably got a home run on your hands.
And that really leaves just one final question, and this one's for you to answer. Think about the projects you're working on right now, the designs on your screen, the problems you're trying to crack. Now that you have the framework, which one of your parts is going to pass the test?